Hi, it's Steve Mayne of IPI here with Ed from Monte Verde. Ed, during our travels through Ecuador and seeing different mining assets, you've been telling me there's a variety of different deposits gold and precious minerals can be found in. We've got a selection on your desk. Would you be as kind just to talk us through them and the advantages and disadvantages of each one, perhaps?
Absolutely. And as you know, gold comes in various different shapes and forms. You know, it came here from outer space and hit the Earth through a supernova explosion millions of years ago. But the one thing that was the common was how it got collected. Many of it got caught in what they call vein systems, which was due to folding mountains, high pressure, melting of silicone, capturing it into a soup. Others fell into a disseminated mode, which means it was spread out widely and just gathered slowly through gravitational pull and gathering of each other. And then inside that, it comes from the different forms of how we choose our processing, from being an oxidized or a sulfide base. So first, let's talk about the quartz. Inside the quartz formation, you know, when the mountains came together out of the tectonic plate folding, the silicone went up to 600 degrees Celsius, melting it into a liquid soup that gathered the gold and formed the walls in which it captured the gold, copper, silver, pyrite, arsenic, all the metals that we today collect. So we look for the white milky quartz to be a very good collection center. The second is we go for the disseminated gold. Disseminated gold came to us in various different forms. This happens to be calcium. This is from salt from the sea. We found this at 3,000 meters above sea level. Now, how did salt from the sea get 3,000 meters up in a mountain? And because of the folding mountains, again, when it came out of the ocean, it went up straight up in the sky. But inside these crystals is the gold. So this is the easiest form for us to crush. Normally, the higher deposits are found in this material. And because remember, gold, when it originally came to the earth, was 1,000th the size of a sewing needle head. So this could be a great collection point for a lot of gold.
So what you're saying is just the one you're holding now, if you just want to hold that up again for the camera, I'll zoom in real close, is that even though we can't, like, by the naked eye see the gold here, this is really what we're trying to find. So in our ideal mining deposit, this is what we'd be taking out of the ground because this will have the highest concentration of gold. Is that correct?
This would have a high concentration, and you can see inside all the crystal, this is very coarse. The gold would go inside because remember, this was at the bottom of the ocean, and it would wash around. The gold would crawl inside one of the cavities here and would be stuck. And when it got stuck inside there, you know, the calcium built up again, and another particle got stuck, and another particle got stuck. This here just happens to be a piece from a deposit that's averaging 24 to 32 grams per ton. So it's an entire mountain of this material.
So in what you're holding, that will have 24 to 30 grams per ton of gold.
Yes.
So you might be able to buy a Mars bar or something with that bit of rock, right?
You definitely could.
Excellent. Let's move on to the next one then.
Okay. And the other one is when the gold gets caught in what they call the host rock. So this has heavy specific gravity. If you were here physically with us, you would be able to see the difference in weights of this versus the quartz versus, you know, the oxidized versus the coral, you know. And this here is a very heavy sulfide rock. It has high copper, it has high silver, it has high gold, but it is very, very heavy. It's by mass, the one on the left is about 3 times the weight of the one on the right.
Sure. So really, it's the density of the rock here you're looking at.
The density. It's the specific gravity of the precious metals that got captured inside this rock. Now, one of the things that we have to look for is the rock being clean or the rock having oxidation on it. You know, oxidation tells us that it's been exposed to water and air, but it also tells us the different metals that's inside. Certain metals we can use different processes of a cyanide process, a ball mill cyanide process, or we can use a straight up flotation process with reagents. So all these things have different signs that tells us what works the best to get the maximum recovery.
Excellent. And so And yesterday when we went and looked at one of your current production plants that's producing, that was a cyanide method, is that correct?
That was cyanide, which is perfect for the oxidized. What we look for is high gold, high silver. When you look into the copper area, you want to use reagents, so you got to go to flotation for maximum recovery rates.
Okay, look, thanks for that. What we'll do is go on to the next video where you can just explain what the production process is in a bit more detail, if that's okay with you.
That's great with me.
Excellent. Cheers, Ed.
Cheers.